Hello and welcome back to Mikey's Flightdeck and to a new configuration video, this time with the first officer's upper MIP panel. This is the first officer's upper MIP panel and the topic of this video. I will show the configuration of all the devices now in more detail. I have made already a video about the basic configuration in Prosim and MobiFlight already, but from time to time I think I can go more into detail so that also new visitors of the channel will have an idea where to start when you are building your own panels at home. I will start with the configuration of all the LEDs of the buttons and annunciators, then make the configuration of the buttons, the test switch and the two rotary switches here. And at the end, I will configure the stepper motor of the gauge. This is my connection sheet that you can download from my website to have a look at some of my used offsets, or if you want to make your configuration like mine, then you are free to download it. Here I'm documenting all the configurations and connections for later maintenance. I'm starting with the letter of my Arduino. I've given them letters starting from A. Here you can see we are configuring the Arduino M today. I'm writing down the pin I'm using on the Arduino for a special configuration. Here are some different labels. I'm coming to this later. I'm writing down the type I'm using, an LED, a stepper motor, a button, or anything else. The name that Prosim uses in its configuration sheet so that I can find it there. And in case that it is an LED, the color of the LED I'm using and the resistor I'm needing for this LED. The Prosim type of offset I'm using, most of the times I'm using 8-bit unsigned types, and this means that I'm storing the value of the configuration in a single bit of the offset that contains 8 bits. Here I'm writing down the offset I'm using and the hex number of the bit that I'm using from this offset. I've learned that it is a good practice to write down my last used offset here so that I'm always on top which offset are still free to use. And here are some ranges of offsets I can use for my project. So the last offset I have used is the 533E offset, and there are still some bits of it empty, and I've written them down here so that I can see these are still unused and free bits for later upcoming configurations. And I'm writing down the D-sub connection plug here, M3, so from the Arduino M, and it is my third D-sub connector for this Arduino. And this is important for later soldering or desoldering the pin of the D-sub connector where the cables are connected to. The mystery behind this code here, SR211 and so on, is that these LEDs are not connected directly to a pin of the Arduino Mega, but I'm using shift registers, output shift registers. MobiFlight lets you cascade up to 4 of these registers in a row and control them with only 3 pins. And every shift register can give us 8 outputs for LEDs. So with these 3 registers, I can control up to 24 LEDs with only 3 pins. Up here you can see I'm using these 3 pins here to control the shift register, the latch, clock and data input. I have written down that these are 3 segments and the name of it is shift register 2, or the short form SR2. And so every output of the register is written down here, starting by SR2 0, 1, 2, 3, and so on. And so I know later in the configuration which output I have to choose when I'm making this configuration in MobiFlight. Let's start now with the configuration in Prosim. For this, you open Prosim System and go to Config and Configuration, and then to the Combined Config tab. It is divided into several sections here, and when I start searching for a configuration offset to insert here, in this case, I would say I have to search in the MIP section, and there under Indicators. And you can see I have already started to insert some of these offsets here. Let's start with all these autopilot buttons here. The other AP Ember First Officer, you can find the configuration here, and I have inserted an FSU IPC 8-bit unsigned offset, and in my case I want to use the offset 533A and the bit 6, and this you insert here like 0x533A.6. Yes, and as I see, I have already done this already for the red First Officer LED. The AT Ember is configured 533C.1. The red light is configured, and also the FMC light is already configured. So these are already inserted into Prosim. The last LEDs that are still missing is the below glide slope. And we will find this here, below glide slope First Officer. Yes, I have already configured this. And the last one, the speed brake extended. This is ordered alphabetically here. You can find the speed brake extended here. And this is the moment when I'm using the search function. Just insert speed brake up here. And you see there are some results in the throttle MCP section and the Michelangelos tab here. And when you look down here, you can see a gate, and there is speed brake extended. So this is not an indicator for Prosim, but a gate. And there I have configured and inserted the offset. So all the LEDs are already configured in Prosim. And go on with all the buttons now. Again, to the MIP section and to switches. And here I'm working my way down through my connection sheet here. The AP Reset First Officer button, AP Reset First Officer, and I'm searching for the push button. There it is. Okay, I see I have already configured them and inserted the offsets. First Officer 80 pushed is there, and the FMC Reset First Officer pushed is there too. The ASA test switch from the captain is there, and from the First Officer, there it is, 1 and 2, the offsets are inserted. And now let's look for the main panel DUS. There's the captain section, and the First Officer section is still missing, so we can insert this now. Well, this is a good example. First Officer outbound PFD. First Officer outbound PFD here. So I'm choosing FSU IPC 8-bit offset and insert the offset I have planned 533D, and the bit is 2. I'm copying this for the next configuration, which is the normal setting. Again, 8-bit offset, and insert it here. And this time bit number 3. Engine pry. There it is. bit number 4, PFD, bit number 5, and the last one, the MFD, bit number 6. Now the 3 settings for the lower DU. There it is, the lower DU for the first officer. Engine pry, there it is, 8-bit unsigned offset, and I'm using 533D bit number 7. Next is the normal position, there it is. And I'm starting with the next offset, 533E.1. And while I'm inserting this offset here, I see that I have made a mistake at some of the last offsets here. The offsets, or the bits of the offsets, are starting from 0, not from 1, like I have written down it here. But instead of changing all my configurations here now and adding 1 to all the bits here, I have seen that there are only 3 offsets, the last 3 offsets, where I have forgotten to start from 0. And so I have just written them down here into my list of unused offsets, C, D, and E. And from these offsets, I have the 0 bit still available, and I can use it for later configurations. So where did we stop? So the normal position, 533E1, there it is, 533E1, and the last one, the lower DU, first officer ND, we are using FSU IPC 8-bit 533E point, there we have it, 2. So this is the configuration of all the buttons. And the last thing is the gauge. Maybe I have already configured this. Here is the stepper motor. It is the name brake pressure. Let's search for this in Prosim. Brake. We have this up here in the hydraulic system, a gauge, there it is, brake pressure, yes, and I have already configured this. For a stepper motor or also a servo motor, I'm always using a full offset, so the offset 533B is inserted here. You don't have to write down a bit, and this I'm documenting here in the configuration too. I'm inserting blanks here so that I know I haven't made a mistake not inserting hex values here. I know that I want to use the full offset to control the stepper motor. So this was the configuration in Prosim. Now let's go over to MobiFlight and make all the needed configurations there. At the beginning, I will declare all the devices for MobiFlight, and you can do this up here in the MobiFlight modules tab. The only Arduino connected to the PC is my Arduino M. Here are already some components for the captain's side panel, and I have already declared the shift register. You can see I have already assigned the corresponding pins, 10 for latch, clock 11 and 12 for data, and I have declared that there are 3 shift registers, and I've given it the name SR2 like I've noted here. All the LEDs, don't be extra devices here, because this will be made just by the upcoming configurations. So we have to declare only the rest of the buttons. And for this, I go to the Add Device button here and add a button. So the first button is the M41 and is connected to pin 16. Next button, M42, is connected to pin 15. And so I will make my way through all these buttons here. Now all the buttons are declared here, and I upload the configuration to the Arduino. The upload is finished and I can click OK here. Now I will start configuring the LEDs, and this will be done here in the Output Configs tab. I make a double click down here to declare a new configuration. I will start here with the speed brake extended LED, which is my number M34, and this is the name I'm giving the configuration. So there it is, and I'm clicking on this button here to go to the detailed configuration. I will use the FSUIPC offset, and the offset I have declared here. This is 533A. And the bit I'm using is bit number 4. I can clear this all and check the number 4. So now I have declared the offset and have to say which display this will use. The type is a shift register. It is the SR2 shift register, and the output here is number 11. There it is. Now we can already make a test, and then speed brake extended down here should illuminate. There it is. And I say stop again. Now, to not make all the configurations from the beginning, we can just copy this line here. So duplicate it and give it the next number, M35. We change the output. This will be number 12. Let's test it already. It is here the below glide slope LED here. There it is illuminating. Say stop, and we just have to edit the offset. Again, 533A, but bit number 5. There it is. And the configuration is finished already. So, and this is how I'm making my way through all the LED configurations. I've done now the configurations for the LEDs M34 up to M40. We will make the final testing at the end when we will test the communication with the simulator and Prosim together. Now let's switch over to the input configurations where we configure all the buttons. Like before, we are going through the list here and starting with configuration M41 for the AP reset button. I make a double click down here and give the configuration the name M41 and go to the details. I say the module is my Arduino M. The device I have given the same name like the configuration, so I have to choose M41 too. And now I have to define two settings, the on press and on release state. The action type is an FSUIPC offset, because when it is pressed, I want to send out the event via FSUIPC. I enter the offset I have declared. This is 533C. And again, the bit, in this case, this is bit number 4. And in the on press state, I'm sending a 1. The button is pressed. Now I can copy this all here and insert it in the on release tab here. And the only thing I have to change is the set value. When the button is released, then I will send a 0. And this is what I have to do now with every button that is following here. If you haven't seen this in the construction video before, then we now will have a look at the stepper motor and how the 0 switch of this motor is made. Back here, behind the panel there is the stepper motor, and here is our optical sensor that will act as a switch for the 0 position. There is a coupler on this stepper motor that connects the shaft of the needle here with the shaft of the stepper motor. And on this coupler there is a nose modeled here, and this nose goes between this optical sensor here and interrupts the light beam. And so every time the stepper reaches its 0 position, then the signal of this component is a 0, and when the needle isn't in between there, then the signal is a 1. Here's the schematic how I connected my optical sensor to my Arduino. This is a component here, and when you look on the outside of the component you will find the pins marked with the letters E and D, and the other two with a plus sign. This part here is the LED that emits the light beam, and the part down here is the receiver part. Let's start with the LED. Both lettered pins will be connected to a ground connection. This is very easy. The pin of the LED with the plus sign will be connected to a resistor of 180 ohms and then connected to 5 volts. The plus pin of the receiver will receive 2 connections. The first one is also a resistor of 2 kilo ohms, which will then be connected to 5 volts. And in front of this, there will be the cable that will be connected to the pin of your Arduino that will receive if the light is received or not. The stepper motor I'm using is the 28BYJ48. It is driven by 5 volt and it comes directly here with a plug mounted on the stepper. You can buy it in a package with this driver here, where the plug of the stepper motor can mount it in here. So no more connections are needed to the stepper motor. This driver is designed so that you can drive motors with 12 or 5 volts. In the standard configuration there is a jumper here, and so it is said that you want to use 5 volt to drive the motor, and the first pin here is the ground connection and the second one is a 5 volt connection. There are 4 more pins here at the side. These are to communicate with the driver here, and these 4 pins will be connected to 4 pins of your Arduino. The use of the optical sensor as a 0 input will bring us a little bit of additional configuration work here in MobiFlight, but I will go through this in detail. Let's start with the stepper motor and have a look to the connection sheet here. The 4 pins that control the motor will be pin 70 to 20, and in the order that pin 20 controls pin 1 of the stepper motor controller board, 19 pin 2 and so on. And I'm naming devices like the numbers here I have declared so that I can find them easier in the alphabetical order in MobiFlight. So I will add a new stepper motor, and as I have said, the name will be M30/33. So I know the pins 30 up to 33 are controlling this stepper motor. So I have to reorder the pins here and say pin 1 is pin 20 and 19, 18 and 17. I will disable the stepper when it's at its target position, and now comes the optical sensor. This will act like a button in MobiFlight. So add a button, and the sensor here, like is written down in the connection sheet, is connected to pin 30. And we will need another output. I will come to this later in a moment when I describe my thoughts behind this all. So I will make an output here, The configuration is M55 and it is connected to pin 32. Let's upload the configuration now here and now come to the theory behind this. The configuration that I will do now in MobiFlight might be a little bit confusing, and so I decided to visualize a little bit more what I'm planning to do now. Our component, the optical sensor, is connected to a pin of our Arduino. Here is where the on-off signal comes in. And I will declare a button device in MobiFlight, like a button is connected to this pin here. So every time when the finger of the motor coupler isn't in between this component, then it is a positive signal here and it's like the button is pressed. And when the finger comes in, there is no light beam coming through, and so it's like a release of this button. And this state of the button will be stored in a variable. This is an internal variable in MobiFlight that I would declare and I can use later. Now we will make a configuration in MobiFlight, and this will be like following. It will take the value of the variable, so it will get the value from the stored variable here and will invert it. So a 0 will become a 1 and a 1 a 0. And this I will give out like an output. So I will declare an output device like an LED that is connected to a pin of the Arduino, and this pin will show the inverted signal of the variable. So every time when the finger isn't in between this component, then there will be a 0 here at this pin. So the LED, if we would connect one, would be off. And if the finger comes into this component here, then the changed value will be a 1 and the LED would be on. But we now need to get this value here to the pin that we have declared as the 0 pin for the stepper motor. And this will be easily done by connecting this pin to the 0 pin that we have declared before in the configuration of the stepper motor. Let's now start with the configuration of the stepper motor in MobiFlight. I will add a new configuration, M30/33, so I know which pins are controlling this motor here, and enter the configuration. It will be controlled by FSU IPC offset, and the offset I have declared here is 533B, the full offset. 533B. The size is 1 byte, and now go to the display tab here. The module is my Arduino M. It is a stepper motor. It has chosen the only available stepper motor here. And now I have to set the display scale. How many steps are on this display? I will concentrate on the value that come in from FSU IPC. And because I'm using 1 full byte, I will have the values 0 up to 254. And so I'm entering here 254. These are the steps of a full revolution. And this will be compared to the steps of my stepper motor that can make 2040 steps for 1 revolution. And because my end stop is positioned absolutely random here, I will activate the compass mode so I can turn over the 254 value, and otherwise it would turn back and then starts again from 0. And you will see this later in the configuration in Prosim. This will be very helpful here. So this is the configuration of the stepper motor. Now let's do the input configuration of our optical sensor. As I have said, this will be configuration M54. let's go into it. The module is my Arduino M and the device M54, which is the button. The optical sensor acts like a button. When the button is pressed, so it is coming a 1 from the device, then I will store this into a MobiFlight variable, which I call like the device here, M54. And I will store a 1 into this variable. Let's copy this and paste it here. For the on release state, so when the button isn't pressed, a 0 is coming, I will store a 0 into the variable. And at the end, we will need another output configuration. This will be here M55, and it will look to the MobiFlight variable M54 that we have declared. And I think the easiest way is to use a comparison here. We'll apply a comparison. If the value is 1, then set it to 0, otherwise set it to 1. So it will flip around the value of the variable. And then it will give out the flipped value to a pin, and we will use this output device here, an output M55, which we have declared as a MobiFlight device. So this configuration is giving out the changed value to pin 32, which is connected to this device. And because pin 32 is directly wired to pin 34, pin 34 can act as an auto 0 pin for the stepper motor, which we can set. We could set this before, but I will do this now here. So the stepper motor will now have an auto 0 input on pin 34, where the changed signal is coming in. Upload the configuration, and we are ready to go for the configuration in Prosim. And therefore we go again into the configuration and to the combined config tab and go here to our brake gauge. I have done this before here to check something out, but for you again, your goal is now to set some defined points on your gauge. And for this, we will click Run in MobiFlight so that a change here and a change in this offset is recognized by MobiFlight and it can react on it. So you can now slide these sliders here so that the needle will go to the point here. Now the goal is to set the needle to 0. Yeah, I think this should work, and the others should still be right too. So the 1000 setting. Yeah, there it is, 2000. Yeah. And 3000. There we are, and 4002. Yes, and that's it for the configuration here. We can already test if the gauge is right. I have running prepared in the background to have FSU IPC running. Prosim is running, MobiFlight is running, and here is Prosim displays. So the gauge, and this should be actually at 1000. And when we look here at the gauge, 1000 is there too. So this is already working. Let's test now the other devices of this panel here and start with the rotary switches. These are not modeled in Prosim display, so we will look up the values here in the system application. And down here we find the lower DU of the first officer, which is in normal state. This is correct. Let's switch to ND. There it switches to ND, normal again, and engine, pri, and normal. This works. The main panel of the first officer, here is it, normal and outbound and engine, PFD, there it is, and inbound MFD right, and back to normal. So these switches are working. Now to the test switch here, and I think we can see this directly with the colors. Test mode 1. All orange annunciators are illuminated, and 2. The reds and the orange annunciator is illuminated. So this switch is working too. Now let's test the button function here. There we have the 3 buttons, AP, AT and FMC of the first officer. Let's start with AP. There it is pushed. AT pushed and FMC pushed. Perfect, it's working. Oh, let's test now the last 2 LEDs down here. The below glide slope at the beginning. Here we have it, below glide slope first officer, and test it. This is working. And the other one we remember is a gate in the Mission Angeles tab here. And here we have speed brake extended. And there it is. So I think this one here is lighting up green. It should be a green light. I will check this out and eventually correct the LED in there. But all in all, our configuration is working now. So this was the configuration of my first officer's upper MIP panel. I hope you find the detailed look into my configuration workflow and my thoughts behind this useful. Don't forget to subscribe to the channel and stay tuned for new upcoming videos. And I hope we'll see us soon back on the flight deck.